Welcome viewers. In this video we'll see the Kirchhoff's law. There are two laws available, Kirchhoff's current law and Kirchhoff's voltage law. First we'll see the Kirchhoff's current law. It's called KCL, Kirchhoff's current law, KCL. The statement of Kirchhoff's current law is that in a node the sum of entering current is equal to sum of leaving current. If we consider any node, the current entering into the node is equal to current leaving to the node. And in other case, the summation of total current at a junction is equal to 0. Otherwise, the sum of the current entering and current leaving is equal to 0, right? So that can be written as sum of current entering equal to sum of current leaving. So if we consider any node, the total current will be 0. That is, while adding the current entering and while adding the current leaving, adding these both, the total current will be 0. The current entering is treated as positive, current leaving is treated as negative. By adding these two, we'll get the total current as 0, right? We'll see in the diagram so that you are able to understand. Now consider this diagram. There are 4 branches available. So R1, in branch 1, the resistor R1 is available. In branch 2, the resistor R2 available. In branch 3, resistor R3 is available. In branch 4, the resistor R4 is available. So all these branches are connected at this point. This point is called a node or junction point. Right? 4 branches are available. All are connected at this point. It's called a node. We have R1, R2, R3 and R4. 4 resistors are available. The current in the first branch is I1, second branch is I2, third branch is I3, fourth branch is I4. Now see that in branch 1 and branch 3, the currents are going towards the node. Currents are flowing towards the node. That is, current is entering the nodes, I1 and I3. The current flowing through the first branch and second branch, I1 and I3 are flowing towards the node. I see the current flowing through the branch, second branch and fourth branch, I2 and I4. So current or the current is leaving the branch. Current is going away from the branch. See the direction, current direction. I2 and I4 are going away from the node. So I1 and I3 are going towards the node, I2 and I4 going away from the node. So these two, I1 and I3 is taken as a incoming current. I1 and I3 is the incoming current. I2 and I4 is treated as a outgoing current, right? Going away from the node. So according to the Kirchhoff's current law, incoming current, sum of incoming current equal to sum of outgoing current. That is, I1 plus I3 equal to I2 plus I4. The current entering the node, the sum of current entering the node is I1 plus I3. That is equal to sum of current leaving the node, I2 and I4. So this is the statement given by the Kirchhoff's current law. The summation of current entering the node is equal to summation of current leaving the node. Now bring this I2 and I4 from right hand side to left hand side. What will happen? I1 plus I3, this minus I2, this I2 while coming this side minus I2. I4 will coming this side minus I4. That is, I1 plus I3 minus I2 minus I4 equal to 0. That is, the summation of total current at a junction is 0. So these two are incoming current, so it is treated as positive. These two are outgoing current, so it is treated as negative. So while adding all 4 current, it is equal to 0. So that is the statement given by the Kirchhoff's current law, right? So the sum of incoming current is equal to sum of outgoing current. And other statement, the sum of total current in a junction is equal to 0, right? So this is the statement given by the Kirchhoff's current law. Now we'll go to the Kirchhoff's voltage law. Now we'll see Kirchhoff's voltage law, KVL. It is also called as a KVL, Kirchhoff's voltage law. What is the statement given by the Kirchhoff's voltage law? The algebraic sum of voltage around any closed path is 0. If we consider any closed path, the voltage around the closed path is 0. So in the previous case, Kirchhoff's current law, we consider the node, junction point. In Kirchhoff's voltage law, we consider closed path, right? In order to apply KVL, what we need? Closed path is needed. In the closed path, we can apply the KVL. In the closed path, the voltage is 0. In case of Kirchhoff's current law, what we need? Node. At a node, what is the current? What is the incoming current and what is the outgoing current? That is analyzed by Kirchhoff's current law. In voltage law, we are analyzing the voltage in a closed path. In other words, in a closed path, the total EMF is equal to 0. The total EMF. The one EMF may be positive, one EMF may be negative. While adding all the EMF, the total EMF is equal to 0. That is the other. In other words, we can say that total EMF is 0. That is, we can say in a closed path, potential rise is equal to potential drop. Right? Potential rise is equal to potential drop. Otherwise, total potential is equal to 0. Now we'll see this diagram so that you are able to understand. Now consider this closed loop. In KCL, we consider one node, junction point. Here we are consider one closed path. There are three resistors are connected in series, R1, R2 and R3. That is, supply is given. These three resistors are energized by this voltage source, DC voltage source. Right? R1, R2, R3, three resistors are connected in series. That is energized by the voltage V. This I is the current flowing through the closed circuit. Because of three resistors connected in series, the same current I is flowing through all three resistors. The voltage drop across R1 is V1. The voltage drop across R2 is V2. Voltage drop across R3 is V3. Right? So we have three resistors connected in series, energized by the voltage source. The current flowing through the circuit is I, total current is I. The same current is flowing through all three resistors. V1 is the voltage drop across R1, V2 is the voltage drop across R2, V3 is the voltage drop across R3. According to the Kirchhoff's voltage law statement, what is the statement? In a closed path, the voltage around the closed path is 0. Otherwise, potential rise equal to potential drop. What is potential rise? What is potential drop? So this is the supply voltage. It's called a potential rise. The potential is given from this voltage source. This voltage source, what is given to the circuit, is dropped across R1, R2 and R3. This is called potential drop. The applied potential is potential rise. That potential is dropped across three resistors. Depends upon the value of R1, R2, R3, the voltages will be dropped. Right? If more resistor means more voltage will be dropped. So based on R1, R2 value, the voltage will be dropped. So the applied voltage potential rise is equal to potential drop across three resistors. So that is given here. E equal to E is, that is V or E, both are same. The potential applied E or V is equal to V1 plus V2 plus V3. Voltage drop across R1, voltage drop across R2 and voltage drop across R3. So this is a statement given. In a closed loop, potential rise is equal to potential drop. Now bring this V1, V2, V3 from right hand side to left hand side so that it becomes negative. E minus V1 minus V2 minus V3 equal to 0. What is this? In a closed loop, the total potential is equal to 0. So one potential is rise, other potentials are drop. So while adding these two, we'll get 0. So another statement given by the Kirchhoff's voltage law. In a closed path, the total EMF is 0. So how will you find V1? V1 is nothing but voltage across R1. So V equal to IR, the general formula. So V1 equal to I into R1 because I is common. Same current is flowing through the all resistors. So V1 can be written as I into R1. V2 can be written as I into R2. V3 can be written as I into R3. So we can write the final equation E minus I1 IR1 minus IR2 minus IR3 equal to 0. So this is the final equation. The potential across potential in a closed path is equal to 0. This positive indicate potential rise, negatives indicates potential drop. While adding these two, we'll got 0 value. So that is a statement given by the Kirchhoff's voltage law. So in this video we discuss Kirchhoff's current law and voltage law. Kirchhoff's current law, what we need is node. We are analyzing what is the incoming current and outgoing current. Kirchhoff's voltage law is applied in a closed path. We are dealing what is the potential drop in a closed path. What is the potential rise or potential drop in a closed path. Thank you. Welcome viewers. In this video we will see the nodal analysis. The nodal analysis is the method to find the voltage at that given node. Node is nothing but a junction point. At a junction point we can find the voltage by using the Kirchhoff's current law. By using Kirchhoff's current law we can find the voltage at the given node. In previous method we have mesh analysis. Mesh analysis used to find the loop current. In a closed loop, what is the current flowing in the closed loop? By using Kirchhoff's voltage law. That is available in the another video, the description box, the link is available. The viewer can see the video, mesh analysis. So this one, nodal analysis. Finding the node voltage using Kirchhoff's current law. So in node voltage method, one of the principal node is selected as a reference node. The common point is selected as a reference node. All other principal node, the voltage is assigned. Other than the reference node, other node, the voltage will be assigned. This voltage is with reference to the reference node. All the node having the voltage, the reference is be reference node. At each principal node, KCL is applied and the equations are obtained. We can apply the Kirchhoff's current law at each node and we can frame the equation. By solving the equation, we can find the node voltage. Right? In that there are two methods available, equation method and matrix method. First we will see the equation method by framing the equation. Now consider this diagram. So we have one network is available. The two voltage sources available, VA and VB. Here the resistors available, R1, R2, R3, R4 and R5. Now we need to assign the node as well as reference node. So this is the reference node. This is common point. All the elements are connected here. So this is the reference node. Another two nodes available here, node 1 and node 2. So what is the mean by node? It is a junction point. See this node 1, R1, R2, R3 are connected together. Similarly at node 2, R2, R4, R5 are connected together. So node is the junction point. At that particular voltage will be assigned. Here node 1 voltage V1 is assigned. At node 2 voltage V2 is assigned. So this is nothing but VA, supply voltage. At this point VA will be available. At this point VB will be available. So we have two voltage sources. The resistors are available. We assigned one reference node at the bottom. Normally it's a return path. Then we assigned the two nodes, node 1 and node 2 at this point. At node 1 the voltage is V1. At node 2 the voltage is V2. The node is nothing but junction point, in that the elements are connected together. So our aim is to find this voltage V1 and V2. What is the voltage at this point? So here we are going to apply the Kirchhoff's current law. What is Kirchhoff's current law? At a junction, incoming current is equal to outgoing current. Incoming current means current flowing towards the node. Outgoing current means current flowing away from the node. Both are equal. Otherwise, at a junction, total current is equal to 0. If any junction, if we add all the current, it will be 0. One current may be incoming current, one current may be outgoing current. So the total current is 0. That is given by the Kirchhoff's current law. Incoming current is equal to outgoing current at a node, otherwise at a node the total current is equal to 0. So we are going to apply this Kirchhoff's law, Kirchhoff's current law at this node 1. What is that? We need to find what is the current in this node. There are three elements available, R1, R2 and R3. So we need to find what is the current through this R1, what is the current through this R2, what is the current through this R3. By adding all this current, that is equal to 0. That is the Kirchhoff's law given. Kirchhoff's law given that the total current in a node is 0. How will you find the current in this branch? Current I equal to V by R. R is available. R is R1. What is V here? This R1 is connected between these 2 points. At this point the voltage is V1. At this point the voltage is VA, the supply voltage. So voltage across this R1 is V1 VA. The difference between V1 and VA. So we consider the node 1. So it is V1 minus VA. Always we need to refer this node 1 because we are going to apply the Kirchhoff's current law at node 1. So V1 minus VA is the voltage across R1. Right? So we need to find the current through R1. Current I equal to V by R. V is nothing but V1 minus VA because R1 is connected between the node 1 and the supply voltage. So the difference between these two voltages is the voltage across R1. So V1 minus VA divided by R1. So this is the current flowing through resistor R1. Then what is the current flowing through the resistor R2? So R2 is connected between node 1 and node 2. The node 1 V1, node 2 is V2 voltage. Right? So the voltage across R2 is V1 minus V2 divided by R2. So this is the current flowing through the resistor R2. Then one more resistor available, R3. So R3 is connected between V1 and reference. Normally the reference voltage is 0. So only V1 is available. So V1 divided by R3 is the current flowing through the resistor R3. So that is equal to 0. So that is a statement given by Kirchhoff's current law. The sum of flowing current in the junction is 0. So in this junction there are three current. One is current flowing through R1, R2 and R3. So this is the current flowing through R1, R2, R3, that is equal to 0. Right? So current is nothing but voltage by resistance. Resistance value available. Voltage we are calculated from this. V1 minus VA in case of R1. V1 minus V2 in case of R2. V1 minus 0, that is V1 in case of R3. So that is very simple. So by using that we framed one equation that is termed as equation number 1. Now we can apply the Kirchhoff's current law to the second node, node 2, this second node. Minimum we need 2 equations, then only we can find V1 and V2. We need to find 2 parameters. So we need 2 equations. Now we can apply the Kirchhoff's current law to this node 2, in that the voltage is V2. At node 2 what are the elements available? R2, R4, R5. These 3 elements are connected. Now we need to find what is the current flowing through R2, R4 and R5. What is the current flowing through R2? Current is nothing but voltage by resistance. What is the voltage? It is connected between node 1 and 2, V1 and V2. Connected between V1 and V2. Now we are applying node 2. So we need to refer V2 minus V1. In case of node 1 means V1 minus V2. There we are applying node 1. Now it is node 2 means we need to take node as here. First we need to take node 2, then node 1. So V2 minus V1 by R2. Right. So V2 minus V1 by R2 is the current flowing through R2. What about R4? R4 is connected between second node and reference node. So that only we have voltage V2. V2 by R4 is the current flowing through the resistor R4. We have one more resistor available, R5. What is the current here? V by I. What is the voltage? V2 and VB is connected between node 2 and supply voltage. So V2 minus VB divided by R5. Right? So this is the current flowing through R2, R4 and R5, sum of these is equal to 0. That is a statement given by the Kirchhoff's current law. Now we got two equations. So by solving equation 1 and 2, we can able to find the V1 and V2. Right? So the nodal analysis means we are going to find the node voltage by applying Kirchhoff's current law. This is equation method. One more method is available, matrix method. Now we'll see this matrix method. Now we'll apply the same network for matrix method. The same network is available here. VA, VB and resistors are available. Node 1, node 2, this is reference node. Node 1 voltage is V1, node 2 voltage is V2. Same circuit. But here we are going to apply the matrix method. What is matrix method? We need to frame this matrix. I equal to V by R. I, this is the current matrix. Voltage matrix, this is resistance matrix. What is the formula based on Ohm's law? I equal to V divided by R. So that here written as 1 by R. Here 1 by R. We need to frame the resistance matrix, voltage matrix and current matrix. First we will find the resistance matrix. What is available here? 1 divided by R11, 1 divided by R12, 1 divided by R21, 1 divided by R22. What is 1 divided by R11? What is R11? R11 is nothing but resistors connected in the node 1. 1 refers what are the resistors connected in node 1. What are the resistors connected? R1, R2 and R3. These three resistors are connected at node 1. That is nothing but R11. So I can write 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Right? So R11 is nothing but at node 1 what are the resistors connected, we need to add. What is R12? R12 means the resistor connected between node 1 and node 2. Connected between node 1 and node 2. What is the resistor connected between node 1 and 2? R2. This R2 is connected between node 1 and node 2. So that minus 1 by R2. What is 2, 1? That also same. The resistor connected between second node and first node. Both are same. Connected between first node or second node to first node is nothing but R2. So minus 1 by R2. Right? So R12 and R2 are also calculated. Other than diagonal, these elements are negative. We need to follow the procedure. Other than diagonal, we need to put negative sign. What is R22? R22 is nothing but the number of resistors available in the second node. What are the resistors available? R2, R4, R5. These three resistors are available at the node, second node. So 1 divided by R2 plus 1 divided by R4 plus 1 divided by R5. Right? So R11 is nothing but resistors available at node 1. R1, R2, R3. R22 is nothing but resistor connected in second node. R2, R4, R5. R12 or R21 means connected between node 1 and 2. Commonly connected between node 1 and 2. So by using that we can frame the resistance matrix. Then what is the voltage? V1 and V2. The voltage matrix is V1 and V2. That only we need to find. What is current matrix? I1 and I2. How will you find this I1 and I2? I1 equal to VA by R1. Because current is not available here. We can find the current at this loop is VA by R1. Supply voltage. VA by R1 will give the current in this node. Similarly, I2 can be calculated VB by R5. This supply voltage and R5 will give the current in the second node. Now we framed the resistance matrix, voltage matrix and current matrix. Then how will you find this voltage V1 and V2? For that we need to consider this is the delta. This matrix is nothing but delta matrix. This is treated as delta. See this. This matrix is delta. By finding the determinant value, we can find the del. By finding this determinant, we can able to find the del value. Then we have del 1 and del 2. What is del 1 and del 2? if the first column is replaced by the current. What is current? I1 and I2. I1 and I2 is known as VA by R1, VB by R5. Right? So the first column is replaced by the current matrix, that is delta 1. If the second column is replaced by current matrix, that is delta 2. Right? So delta is nothing but resistance matrix. Delta 1 is nothing but, in the resistance matrix, first column is replaced by current matrix. Delta 2 is nothing but second column is replaced by current matrix. Now we can find the determinant value, delta 1 and delta 2. From that we can find this V1 and V2. Formula is available. V1 is delta 1 by delta. V2 is delta 2 by delta. So finding this by using this formula, we can able to find V1 and V2. So in this video we saw what is the nodal analysis, how to find the node voltage by using two methods, equation method and matrix method. The solved example for this solved problem for this nodal analysis available in the next video. The link is available in the description box. The viewers can see the solved problem in the nodal analysis. Thank you. Welcome viewers. In this video we will see the solved problem for nodal analysis by equation method. The explanation for nodal analysis available in the previous video. The link is available in the description box. The viewers can see what is meant by nodal analysis and what is meant by equation method. The explanation is available. In this video we will see the solved problem. So the question is, find the node voltage and current through the various resistor for the circuit shown below. So this is the circuit available. We need to find the node voltage, these two node voltage, and current flowing through all resistor. Current flowing through 5 ohm, 4 ohm, all the resistor we need to find. That is the two questions. So now consider this diagram. So the two voltage sources available, 25 volt, 100 volt. We'll take this is VA and this is VB. Then various resistors are available. What is node? Node is nothing but a junction point. All the elements are connected together. So we need to assign the node as well as reference node. Reference node is nothing but common point. Normally this common point is taken as reference node. Here the potential is 0, return path. Other than that we need to find the principal node. So we can take this is one node. How we can assign this is node? At this point these three resistors are connected together. We can assign this is the second node. Here these three resistors are connected together. So this is not a node. This is a normal point. So supply voltage is given here. So this is the node. At this three elements are connected together. So we assign two nodes. The problem, the node is not given, we need to assign the node. So this point is assigned as node 1. At node 1 the voltage is V1. This point is assigned as node 2. The voltage at node 2 is V2. This is the reference node. So the question is, we need to find the value of V1 and V2. What is the value of V1 and V2? So our aim is to find V1 and V2. We can apply the Kirchhoff's current law to find this V1 and V2. We can frame the two equations. By solving the two equations, we can able to find V1 and V2. First we'll consider the node 1. We'll consider node 1. Apply Kirchhoff's current law to the node 1. What is Kirchhoff's current law? The incoming current is equal to outgoing current at a node. Otherwise, the total current in the node is 0. That is the total current in the node. What is the total current? Current flowing through 5 ohm, current flowing through 4 ohm, current flowing through 10 ohm. By adding these three is equal to 0. That is the statement given by Kirchhoff's current law. The total current in a node, in a junction point is 0. What is the current flowing through this 5 ohm resistor? The formula current is nothing but I equal to V by R. the current I equal to V by R. What is the V? What is the voltage across this 5 ohm resistor? So it is connected between node 1 and supply voltage. So the node 1 voltage is V1, supply voltage is 25 VA. So V1 minus VA, that is the voltage across 5 ohm, divided by R. R is nothing but 5. Right? So V1 minus VA divided by 5. This is the current flowing through the resistor 5 ohm. This 5 ohm connected between V1 and VA, so that it is V1 minus VA. What is the current flowing through this 10 ohm? This 10 ohm is connected between node 1 and node 2. So V1 minus V2 divided by 10 is the current. V1 minus V2, because 10 is connected between V1 and V2. So while referring the node 1, we always refer V1, V1 minus VA, V1 minus V2, like that. Then what is the current flowing this 4 ohm? That's connected. This 4 ohm is connected V1. So V1 by 4. Another end is the reference. This reference node means the voltage is 0. So the for 4 ohm, it is connected between node 1 reference node, so that V1 by 4. So this is nothing but current in a junction is 0. Current in the junction is nothing but current flowing through 5 ohm, 4 ohm and 10 ohm. That is calculated. The current I equal to V by R. So all are added together. So V1 by V1 minus VA is nothing but 25 divided by 5. V1 minus V2 divided by 10. V1 by 4, here is equal to 0. We'll take this is equation number 1. We can go for further simplification in the equation. Now we'll apply the Kirchhoff's current law to the second node, node 2, this node, second node. At second node, what are the resistors available? This 10 ohm is connected, this 2 ohm is connected and 8 ohm is connected. 3 resistors are connected at node 1. First consider this 10 ohm. What is the voltage across 10 ohm? V2 and V1. It is connected between node 1 and node 2. While referring node 2, we need to take V2 minus V1. If you refer node 1 means V1 minus V2. While referring node 2, V2 minus V1 divided by 10. Then what is the resistor current through this 8 ohm resistor? This 8 ohm is connected between node 2 and supply voltage VB. It is connected between V2 and VB. So V2 minus VB by 8. What is the current flowing through this 2 ohm resistor? It is connected between second node V2 and reference node. So that V2 divided by 2, that is equal to 0. Now we calculated current flowing through 10 ohm, 8 ohm and 2 ohm, that is equal to 0. This V2 minus V1 by 10, V2 minus VB, VB is nothing but 100 voltage. So V2 minus 100 by 8 plus V2 by 2 equal to 0. Now frame the second equation also. Now we'll simplify this equation 1 and 2, then we can go for the solving the equation. Before solving this equation 1 and 2, we will simplify this. Now consider the equation 1. Consider the first equation. So this first equation is considered V1 minus 25 by 5, V1 minus V2 by 10, V1 by 4 equal to 0. Now we'll split this V1 by 5, 25 by 5, splitted. The denominator is splitted here. Similarly, V1 by 10 minus V2 by 10 plus V1 by 4. Now it is splitted, all are splitted. Now write all the V1 terms, V1 by 5, here V1 by 10, V1 by 4. Only one V2 term is available, minus V2 by 10. The numerical is 25 by 5 is 5. Right? So in this, all V1 terms are written first, then V2 term, then the constant. Now we'll take the LCM for this, 5, 10 and 4. The LCM is 20. For these three numbers, 5, 10, 4, the LCM is 20. So in the 20, 5 is going 4 times, so 4V1. In 20, 10 is going 2 times, so 2V1. In 4, 20 goes 5 times, so 5V1. Right? So this is normal simplification by LCM. Minus V2 by 10 minus 5 equal to 0. Right? So this 4 plus 2, 6, 6 plus 5, 11. 11 V1 by 20. V2 by 10 can be written as 0.1. 1 by 10 is 0.1. Minus 5 equal to 0. So that 11 by 20 is 0.55. By simplifying this 11 by 20, 0.55 V1 minus 0.0 V2. You bring this minus 5 in the right hand side. So it becomes plus 5. So we'll take this is equation number 3. 0.55 V1 minus 0.1 V2 equal to 5. So now framed the equation 1, equation 3. Now we'll go to the equation 2, then we'll go for simplification. Now let's take this equation 2. V2 minus V1 by 10, V2 minus 100 by 8 plus V2 by 2 equal to 0. Now split the denominators. V2 by 10 minus V1 by 10. V2 by 8 minus 100 by 8 plus V2 by 2 equal to 0. Now it is splitted. Numerator is splitted. Now we'll write the V2 terms. What are the V2 terms available? V2 divided by 10. Here 1 V2 divided by 8. Here V2 divided by 2. 3 V2 terms are available. 1 V1 is available. Minus V1 by 10. And numerical is 100 by 8. Minus 100 by 8. Now we can take the LCM for these three numbers. 10, 8 and 2. The LCM is 40. 40, this 10 is going 4 times. So 4 V2. In 8, the 40 in 8 it goes 5 times. So 5 V2. So the 2 in 40 it goes 20 times. So 20 V2. So this is a normal LCM. Then V2 by 10 can be written as 0.1 V1. 100 by 8 can be written as 12.5. Right. Now we can go for the further simplification. So 4 plus 5 9. 9 plus 20. 29 by 40 V2 minus 0.1 V1 minus 12.5 equal to 0. Then we'll go for the further simplification. This 29 by 40 is 0.725 V2 minus 0.1 V1 minus 12.5 equal to 0. Now we'll write in order V1. First we'll write V1 minus 0.1 V1 plus this V2 0.725 V2 equal to 12.5. This minus 12.5 is brought to right hand side. So it becomes plus 12.5. You take this equation number 4, fourth equation. Now we have equation 3 and equation 4. Equation 1 and 2 is framed from the network using Kirchhoff's current law. That equation 1 and 2 is simplified, then we framed equation 3 and 4. By solving this equation 3 and 4, we can go for the find the V1 and V2. So this is equation 3. This is equation 4. We need to solve these two equations so that we can able to find V1 and V2. See this, in order to cancel V1, here 0.55 is available, here 0.1 is available. So multiplying equation 1 with 0.1 and equation 2 with 0.55, so that these two terms become equal, we can easily cancel. That is, equation 3 is multiplied by 0.1. Equation 4 is multiplied by 0.55. Opposite. This oppositely we multiply, so that these two terms become equal. Right? So equation 3 multiplied by 0.1 will get this. Equation 4 multiplied by 0.5 we will get this. So what is the advantage here? Both are become equal. One is plus and one is minus. So simply we can cancel. We can add this negative. So that by simply adding it will be cancelled. So by adding these two, 0.38875 V2. By adding these two, 7.375. Due to negative we are adding simply. So 0.38875 V2 equal to 7.375. Now we'll go for the further simplification. So it can be written as 0.38875 V2 equal to 7.375 can be written as V2 equal to 7.375 divided by this term. This term is brought in the denominator. So by simplifying this, what we got? 18.97 voltage. The V2, the node voltage at the second node VT is 18.97 voltage. Now we'll consider this third equation. In this, if we substitute V2, we can easily find V1. Right? So V2 is calculated. Now consider the third equation. In that we are substituting V2 equal to 18.97 V2. So 0.55 V1 minus 0.1 into 18.97 equal to 5. Now we can multiply these two. These two are multiplied. So it is 1.897. Now bring this term in the right hand side. So it becomes plus 5 plus 1.897. So by adding these two, 6.897. So that V1 equal to 6.897 divided by 0.5. This term is brought in the denominator. So the simplifying this value, what we got? 12.54 voltage. The voltage at the node 1 is 12.54. So the first question we calculated. Node voltage V1 and V2 is calculated. Second, we need to find what is the current flowing through each and every resistor. Now we'll find the current flowing through. There are 5 resistors available. So the current flowing through the 5 ohm resistor is nothing but VA minus V1 by 5. This already we discussed while framing the equation. So VA is 25 minus V1. V1 we calculated 12.54 divided by 5. It is 2.492 amperes. Then current flowing through the 4 ohm resistor is V1 by 4. So this thing already available in the diagram, that already we discussed. From that you can easily understand. So V1 by 4, 12.54 by divided by 4, it is 3.135 ampere. Current flowing through the 4 ohm resistor. Current flowing through the 10 ohm resistor is V1 minus V2 divided by 10. So 12.54 minus 18.97 divided by 10, that is nothing but minus 0.643 ampere. This is negative. We got the negative value. Then current flowing another 2 resistors available. Current flowing through 8 ohm resistor is VB minus V2 divided by 8. VB is 100, supply voltage, second supply voltage 100, minus 18.97 by 8 is 10.12 amperes, positive only. Then current flowing through the 2 ohm resistor, V2 by 2 equal to 18.97 by 2, that is 9.485 amperes. Now we calculated the current flowing through all 5 resistors. So in this problem, we calculated the node voltage V1 and V2 by using the equation method, and current flowing through all resistors. The explanation of node voltage, that is available in another video, and matrix method also available in separate video. The link is available in the description box. The viewers can see the link and you can see the nodal analysis explanation. Thank you. Welcome viewers. In this video we'll see the solved problem in nodal analysis using the matrix method. What is nodal analysis? The explanation and other equation method available in the separate video. Link is available in the description box. You can view that videos. So in this, the problem is find the node voltage and current through various resistors for the circuit shown below. We need to find the node voltage and current flowing through all the resistors for the circuit shown below. That is the question. Now consider this diagram. So the 2 voltage sources available, 25 volt and 100 volt. The resistors are connected. Now we need to assign the node. So this is the reference node. And this is the node 1. This is node 2. What is node 1? The node is nothing but junction point. Their elements are connected together. So in the node 1, this 5 ohm, 4 ohm and 10 ohm is connected. At node 2, this 10 ohm, 2 ohm and 8 ohm is connected. What is the voltage at this node 1? That is nothing but V1. Here is V2. Right? So we have reference node and 2 different nodes are available. So our aim is to find this node voltage V1 and V2 by using the matrix method. How will you find this matrix method? By applying Kirchhoff's current law. I equal to V by R. So this is the current matrix. This is voltage matrix. This is resistance matrix. 1 divided by R, because I equal to V by R. be divided by R, so that it is 1 by R. Then how will you find this resistance matrix? What is the R11? R11 is nothing but the resistors connected at the node 1. What are the resistors connected at node 1? Is 5 ohm, 4 ohm and 10 ohm. Sum of these three is nothing but the R11. 1 divided by R1, so that 1 divided by 5 plus 1 divided by 4 plus 1 divided by 10. These three resistors are added. That is nothing but R11. R11 is the total resistors connected at the node 1. What is R12? 1 divided by R12. R12 is nothing but the resistor connected between node 1 and node 2. Between node 1 and node 2. This 10 ohm is connected between node 1 and node 2. So minus 1 by 10. So other than diagonal, we need to put the other elements are negative. So minus 1 divided by 10. What is R21? That also same. Connected between second node and first node. That is also 10 ohm. Minus 1 by 10. What is R122? That is nothing but the resistors connected at the second node. What are the resistors connected? 10 ohm, 2 ohm and 8 ohm. So 1 divided by 10 plus 1 divided by 2 plus 1 divided by 8. Now we framed the resistance matrix. R11 is the resistors available in node 1, these three. R22 is the resistors available in second node, these three. R21 or R12 is nothing but resistor connected between 1 and 2. That is this 10 ohm. Then we'll go to the voltage matrix and current matrix. What is the voltage matrix? V1 and V2. This only we need to find. What is the current matrix? I1 and I2. What is the current in I1? I equal to V by R. That is 25 divided by 5. Will give the current in the first node. 25 by 5. Similarly here second, 100 divided by 8. This 100 ohm directly connected to 8 ohm. So 100 divided by 8 will give the I2. So now we framed resistance matrix, voltage matrix and current matrix. Now we'll go for the further simplification. So this 1 by 5 plus 1 by 4 plus 1 by 2, 10 is simplified as 20, 11 divided by 20. By taking LCM, it is simplified. Minus 1 by 10 is minus 0.1. 1 by 10 can be written as 0.1, minus 1.1. This is also minus 0.1. By simplifying this, we got 29 by 40. You need to take the LCM. After LCM, by simplification, we got this 29 by 40. So the 11 by 20 is nothing but 0.55. Minus 0.01, minus 0.01. 29 by 40 is nothing but 0.725. Now it is further simplified. V1, V2. Then this 25 by 5 is 5. 100 by 8 is 12.5. Now we framed the matrix and simplified also. Then how will you find the voltage V1 and V2? So this is nothing but delta 1. By replacing the first column with current, this is called delta 1. So this is delta matrix. By replacing the first column with current matrix is delta 1. By replacing the second column with current matrix is called delta 2. From delta 1 and delta 2, we can easily find the V1 and V2. Now we'll go for the delta. Now we'll frame the delta. So this is delta. This is the resistance matrix. That's termed as delta. Need to find the determinant. How will you find the determinant? You have to multiply these two. 0.55 into 0.725 minus. You have to multiply these two. That is, you know very well. That is the procedure for finding the determinant. We need to multiply these two minus these two. So here already 2 minus available, it become positive, but here one more minus available, so finally it is negative. So by simplifying, what we got? 0.38875. Delta value is 0.38875. Then how will you find delta 1? You have to replace the first column with the current matrix. Current is 5 and 12.5. You have to replace the first column with current matrix is nothing but delta 1. Now multiply these two. Find the determinant, we have to multiply these two. 5 into 0.725 minus these two. Minus 0.1 into 12.5. So here on 2 negative available, so it become positive. The final value is 4.875. We got the delta 1 value. Then how will you find delta 2? That is replacing the second column. The first column as it is. Second column is replaced by current matrix. Right? That will give the delta 2. Then you will find the determinant 0.55 into 12.5 minus 5 into minus 0.1. So the 2 negative available, so it become positive. The final value is 7.375. The delta 2 is 7.325. Now we got the delta value, delta 1 and delta 2. From that, how will you find V1 and V2? The formula is available. V1 equal to delta 1 by del. 4.875 divided by 0.38875. So this is the delta 1, this is delta. So it gives 12.54 voltage. The node voltage, first node voltage V1 is 12.54 voltage. V2, delta 2 by 2. Delta 2 divided by delta. 7.375 divided by 0.38875. That is 18.97 voltage. Now we got the V1 and V2. The same problem solved by equation method. The link is available in the description box. You can see that. We got the same answer. Now we got one answer, V1 and V2. We need to find current flowing through each and every resistors. Now we'll find the current flowing. There are 5 resistors available. We'll find one by one. Current flowing through the 5 ohm resistor is VA minus V1 by 5. That is the resistor 5 is connected between node 1 and supply voltage. So that VA minus V1 by 5. So that value by substituting VA is 25, V1 is 12.54 divided by 5, 2.492 amperes. By referring the diagram, you can easily identify this 5 ohm is connected between supply and first node. So that it is VA minus V1. The current flowing through 4 ohm resistor is V1 by 4 because it is connected in the node 1. V1 by 4. 12.54 divided by 4. 3.135 amperes. The current flowing through the 10 ohm resistor is V1 minus V2. This 10 ohm is connected between node 1 and node 2. So that V1 minus V2 divided by 10. So 12.54 minus 18.97 divided by 10, it is minus 0.643 amperes. This negative. We got the negative value. Another 2 resistors available. Current flowing through 8 ohm resistor. VB minus V2 divided by 8. So it is connected between second supply voltage and V2, second node. So that 100 minus 18.97 by 8, it is 10.12 amperes. And one more resistor, current flowing through 2 ohm resistor, V2 by 2. 18.97 divided by 2 equal to 9.485 amperes. Now we calculated the current flowing through all 5 resistors. The course material for this nodal analysis and other topics available in your drive. The link is available in the description box. You can download the course material, that is study materials. Thank you. Welcome viewers. In this video, we will see the problem based on the nodal analysis by equation method. The problem contains the 3 nodes. The question is find the node voltage for the network shown below. So the network is available here. So there are 3 current sources available. The resistors are connected. By inspecting this diagram, we can easily identify this is the node 1. We'll take this is the node 1. The voltage at node 1 is V1. This is node 2. Node is nothing but junction point. The current source and the resistors are connected together. So this is the second node. The voltage is V2. This will be the third node. The voltage at the node is V3. So this is the reference node, the return point. Reference node, node 4. But the potential at this reference node is 0. So we have 3 nodes, 1, 2 and 3 with voltage V1, V2 and V3. And fourth node is the reference node. So our aim is to find the node voltage V1, V2 and V3. The current sources available, see the current direction. So going in the right hand side. It means it is going towards the node 2, going away from the node 1. Similarly, this current source going away from second node, going towards the third node. Similarly, this one going towards the first node, away from the third node. So the current direction also important. In order to find the V1, V2, V3, we can apply the Kirchhoff's current law to node 1, 2 and 3. We will frame the 3 equations. By applying the Kirchhoff's current law to the each 3 nodes, we can frame the equation. By solving the equation, we can able to find V1, V2 and V3. First, we will apply the Kirchhoff's current law at node 1, at this node, node 1. This is node 1. What is Kirchhoff's current law? The current at a node is equal to 0, or incoming current is equal to outgoing current. Incoming current is equal to outgoing current. So this already 2 current sources available at this node. This 4 ohm available and 3 ohm available. What are the other currents? The current due to this 2.4 ohm resistor and 1 ohm resistor. So these 2 current is equal to outgoing current, these 2. Then how will you find the current flowing through this 1 ohm resistor? I equal to V by R. What is the voltage then? What is the voltage across this 1 ohm resistor? This 1 ohm resistor connected between node 1 and node 2. So the difference between these 2 voltage will appear across the resistor 1 ohm. So V1 minus V2 is the voltage across the first across the resistor R1, resistor 1 ohm. So V1 minus V2 divided by 1. Just this is nothing but a current flowing through the 1 ohm resistor. I equal to V by R. Right? This 1 ohm resistor connected between node 1 and node 2. So the voltage across the 1 ohm resistor is V1 minus V2 divided by 1 will give the current. Similarly, we have one more resistor available at this node, 2.5 ohm resistor. It is connected in the node 1 at a voltage of V1. The another end is the reference node, that is 0, potential is 0. So V1 divided by 2.5 is the current flowing through the 2.4 ohm resistor. So these are all the 2 current is flowing through the 1 ohm resistor and 2.5 ohm resistor. So that is equal to current flowing by the current source. So this 4 ohm is coming towards the node 1. This 3 ohm is going away from the node 1. So this is the incoming current, this is the outgoing current. So 4 minus 3. This 4 ohm is plus 4, but this 3 ohm is the minus 3 because it is going away. So we are subtracting this current. So Kirchhoff's current law is nothing but current at a junction is 0 or incoming current is equal to outgoing current. So we need to find what is the current flowing through this 1 ohm resistor and 2.5 ohm resistor and what is the current due to this current sources. So for 1 ohm resistor we calculated it is connected between the node 1 and 2. So V1 minus V2 divided by 1. The 2.5 ohm resistor it is connected in node 1. So V1 divided by 2.5. That is equal to 4 ohm coming towards the node 4 ampere. This 3 ampere going away from the node 1. So it is minus 3. So we will take this is the equation number 1. Now we will go to the second node. What are the sources available here? This 3 ohm is coming towards the second node. This 4 ohm is going away from the node. So these 2 current sources available. What are the resistors available? This 1 ohm, this 4 ohm and 2 ohm. These 3 resistors are connected at this point. This 1 ohm, 2 ohm and 4 ohm. Now we need to find what is the voltage across this resistor. First we will take this first 1 ohm resistor. It is connected between second node and first node. So V2 minus V1 divided by 1. So while referring the second node, V2 by V1. While referring the first node, V1 by V1 minus V2. Which one we are referring, that should be appear first. V2 minus V1 divided by 1. Then this 4 ohm available. 4 ohm where it is connected between second node and reference node. So reference node the voltage is 0. So V2 divided by 4. This 2 ohm is connected between second node and third node. So V2 minus V3 divided by 2. Then that is equal to what are the current? This current 3 is coming inside. So 3. This 4 ohm going away. So minus 4. 3 minus 4. So in the node 1 we have 1 ohm resistor, 4 ohm resistor, 2 ohm resistor. That currents are calculated. That is equal to, based on the current direction, 3 minus 4 on right hand side. So this is equation number 2. Now we'll apply the Kirchhoff's current law to the third node. At third node, what are the current sources available? This 4 ohm is coming towards the third node. Another 4 ampere. 4 ampere is coming towards the node 3. But another current source 4 ampere is going away from the third node. Right? 4 ampere is coming towards, another 4 ampere is going away. So 4 minus 4. Right? One is incoming, one is outgoing. Then what are the resistors connected at this? This 2 ohm and 5 ohm. These two resistors are connected. This 2 ohm is connected between second node and third node. So V3 minus V2 divided by 2. So while referring the node 3 means V3 will appear first. V3 minus V2 divided by 2. This 5 ohm is connected between node, third node and reference node. Reference node is the potential is 0. So V3 divided by 5. That is equal to 4 minus 4. This is equation number 3. Right? So we need to find node 1, node 2 means first we need to find what are the resistors connected, what is the current flowing the resistor, that is equal to what are the current sources, whether incoming or outgoing. Accordingly we need to frame the equation. Now we will simplify these equations so that we can go for a solution. By solving these three equations, we are able to find the node voltage V1, V2 and V3. First we will consider the equation 1. This equation 1. We will simplify this. Equation 1 is V1 minus V2 divided by 1 plus V1 by 2.5 equal to 4 minus 3. So V1 minus V2 by 2 means 1 means V1 minus V2. V1 divided by 2.5 means 0.4 V1. This 1 divided by 2.5 is 0.4. That is equal to 4 minus 3 means 1. Right? So here V1 is available, here 0.4 V1 is available. So 1 plus 0.4, 1.4 V1 minus this V2, that is equal to 1. We will take this equation number 4. Now equation 1 is simplified and given as given the number as 4. Now consider the second equation, V2 minus V1 by 1, V2 by 4 plus V2 minus V3 by 2 equal to 3 minus 4. So this one can be written as V2 minus V1. V2 by 4 is 0.25 V2. 1 divided by 4 is 0.25. 1 divided by 2 is 0.5. 0.5 V2 minus 0.5 V3 equal to 3 minus 4 is minus 1. Now this V1 is available here, minus V1. V2 available, V2 0.25 V2, 0.5 V2. So 1 V2 plus 0.25, 1.25. 1.25 plus 0.5 is 1.75 V2. Then one V3 term is available, minus 0.5 V3 equal to minus 1. We'll take this equation number 5. Now equation 2 is simplified and framed as, it is named as, given the number as 5. Now we'll take the third equation, V3 minus V2 divided by 2 plus V3 by 5 equal to 4 minus 4. So this 1 by 2 is 0.5. So 0.5 V3 minus 0.5 V2 plus 1 divided by 5 is 0.2 V3 equal to 4 minus 4 is 0. Here the V2 is available. V1 is not available. So minus 0.5 V2. V3 available 2 times. 0.5 V3 plus 0.2 V3. So 0.5 plus 0.2 is 0.7 V3. That is equal to 0. We take the equation number 6. Now equation 3 is simplified and given the number as 6. So from equation 1, 2, 3, we framed the simplified equation 4, 5, 6. Right? So these 4, 5, 6 equations are available. So this is equation 4, 5 and 6. So by solving this equation, we are able to find the voltage V1, V2 and V3. Now consider the equation 5 and 6. In this we are going to eliminate the term V3. Right? From equation 5 and 6 we can eliminate V3. In order to eliminate, here the coefficient 0.5 is available. Here 0.7 is available. So you have to multiply in a reverse order. This equation is multiplied by 0.7. This equation is multiplied by 0.5. So that we'll get the same coefficient 0.35. Right? In order to cancel this V3, this 0.7 is multiplied with equation 5. 0.5 is multiplied with equation 6. So that we'll get the same magnitude, same coefficient in V3. So equation 5 is multiplied by 0.7. This equation available. Equation 6 is multiplied by 0.5. This equation is available. See, these two are same. One is negative and one is positive. So easily we can add these two equations. Because one is negative and one is positive. By adding, automatically this got cancelled. So 0.7 V1 is available. V1 term is not available here. Here 1.225 V2, here minus 0.25 V2. So by adding these two we got 0.975 V2. That is equal to 0.7 minus 0.7. Another term is 0. We'll take this is equation number 7. Right. Now we got V1 and V2. Now consider this equation 7 and equation number 4. See it. In this we can cancel this term. V1 is available here. Here also V1 available. Here V2 is available. Say 0.7 is available. Here 1.4 is available. So if you multiply this equation 7 with 2, here also we will get 1.4. So that we can cancel the term V. Now we'll go for this. Now we are going to cancel the term V1 between equation 4 and equation 7 by multiplying 2 in the equation 7. So equation 4 is 1.4 V1 minus V2 equal to 1. Now equation 7 is multiplied by 2. So that 0.7 into 2 is minus 1.4 V1. Then 1.95 V2 equal to minus 1.4. Now see, these two coefficients are equal. One is positive and one is negative. So simply we can add these two. So this got cancelled. So by adding these two we got 0.95 V2 equal to 1 minus 1.4 is minus 0.4. So V2 equal to minus 0.4 divided by 0.95. That is minus 0.421 voltage. Now we got the second node voltage. V2 is calculated. By solving the equations step by step, we got the value V2. From V2 we can find V1 and V3. Right? So that equations are available here. I will take the equation 1. 1.4 V1 minus V2 equal to 1. Now we know the value V2. V2 equal to minus 0.421. So we will substitute here. 1.4 V1 minus of 0.421 equal to 1. So 1.4 V1 equal 1 plus. So both are negative, so it becomes positive. 0.421 equal to 1. Bring this 0.421 from left side to right hand side. So it becomes negative. 1.4 V1 equal to 1 minus 0.421. So 1 minus 0.421 is 0.579. So V1 equal to 0.579 divided by 1.4. So that is equal to 0.4135 voltage. So V1, the node voltage, first node voltage V1 is, we calculated 0.4135. Now consider the sixth equation. Minus 0.5 V2 plus 0.7 V3 equal to 0. Now here also substitute the V2 value, minus 0.421. So minus 0.5 V2 plus 0.7 V3 equal to 0. So minus 0.5 into substitute the V2, minus 0.421 plus 0.7 V3 equal to 0. Here both are negative. So 0.5 into 0.421 is 0.2105 plus 0.7 V3 equal to 0. Bring this term in the right hand side. So 0.7 V3 equal to minus, it become minus 0.2105. So V3 equal to minus 0.2105 divided by 7. Bring this 0.7 in the denominator. By simplifying this, what we got? Minus 0.3008 voltage. Now V3 also calculated. So the node voltage V1, V2, V3 are calculated. So in this problem, the nodal analysis, nodal voltages are calculated by equation method. The same problem solved by matrix method. The link is available in the description box. The viewers can see that the problem solved by matrix method. Thank you. Welcome viewers. In this video, we will see the nodal analysis by matrix method containing the three nodes. The question is, find the node voltage for the network shown below. For the given network, we need to find the node voltages. Now refer the network. So there are three current sources available. See the current direction. By inspecting this network, we can easily identify, we assume that this is the node 1. Node is nothing but junction point. The current sources and resistors are connected together. It's called a node. So we'll take this is the node 1. The voltage at node 1 is V1. We'll take this is the second node, node 2. The voltage at node 2 is V2. This is node 3. The voltage at node 3 is V3. We have one more node, reference node, the fourth node, but the potential at the reference node is 0. It's a return path. Now see the current direction of this 4 ampere. It is going towards the node 1. That is away from the node 3 and going towards the node 1. Similarly, this 3 ampere away from the node 1 and going towards the node 2. This 4 ampere away from the second node and going towards the third node. So by applying the Kirchhoff's law, we can frame the matrix. From the matrix, we can able to find the node voltage V1, V2 and V3. How will you frame the matrix? By using this I equal to V divided by R. So we need to frame the current matrix, voltage matrix, resistance matrix, resistance 1 by R, because I equal to V divided by R, 1 by R. So this is nothing but a matrix. This is a current matrix, I1, I2, I3. Current at node 1, node 2, node 3. Similarly, voltage at nodes V1, V2 and V3. The resistance matrix is 1 divided by R11, 1 divided by R12, 1 divided by R13, like that. We need to frame this matrix. First, we will consider the resistance matrix. What is R11, 1 divided by R11? R11 is nothing but the resistors connected at the node 1. What are the resistors connected at node 1? We need to identify. That is R11. So at the node 1, this 1 ohm is connected and this 2.5 ohm is connected. Two resistors are connected at node 1. That is nothing but R11. Now we need to add this 1 divided by 2.5 plus 1 divided by 1. So R11 is nothing but resistors connected at the node 1. That is this 1 ohm and 2.5 ohm is connected. So here we need to write 1 divided by R11. So that 1 divided by 2.5 plus 1 divided by 1. What is R12? The resistor connected between node 1 and node 2. See this is node 1, this is node 2. So this 1 ohm is connected between node 1 and node 2. Commonly available between node 1 and 1 2. So this is nothing but R12. So 1 divided by 1. Other than diagonal, other elements we need to put negative sign. It's a general rule. Only diagonals are positive, all other negative, other elements are negative. R13. The resistor connected between node 1 and node 3. So this is node 1, this is node 3. Any resistor is connected? It's not connected. Resistor not connected between 1 and 3. So it is 0. There is no connection between this node 1 and node 3. So it is 0. Similarly, R21 connected between second node and first node. Second node and first node. Same thing. This 1 ohm. This 1 ohm is connected between second node and first node. So minus 1 by 1. R22. What is R22? The resistor connected at the second node. What are the resistor connected at the second node? This 1 ohm, this 4 ohm and this 3 ohm. This 2 ohm. 3 resistors are connected at second node. That is called R22. We need to add all these 3. So this 1 ohm is connected, 4 ohm is connected and 2 ohm is connected. So 1 by 1 plus 1 by 4 plus 1 by 2. So this is nothing but R22. R22 means the resistors connected, sum of the resistor connected at second node. R23. What is R23? Connected between second node and third node. Second and third node, this 2 ohm is connected between second node and third node. So minus 1 by 2. Already this negative, other than diagonal negative. So 2, 3 means connected between second node and third node. So this 2 ohm is connected between second and third node. So minus 1 by 2. Then R31 connected between third node and first node. Between third and first node, then resistors are not connected. No resistors are available. So it is 0. R32. Same thing. Connected between third node and second node. This 2 ohm. So R23 and R32 are same. Connected between second node and third node or third node to second node, same. This 2 ohm. So minus 1 by 2. Then finally R33. What is R33? The resistors connected at the third node. What are the resistors connected at the third node? These 2 ohm and 5 ohm. These 2 resistors are connected at third ohm. So 1 by 2 plus 1 by 5. Right? 1 by 2 plus 1 by 5. Now we framed the resistance matrix. So R11 means the resistors connected at the node 1. R22 means resistor connected at the second node. R33 means resistor connected at the third node. 1, 2, R21 means connected between first node and second node. Like that we need to frame. Now we'll simplify this, the resistance matrix. So 1 divided by 2.5 plus 1 by 1 will become 1.4. Then minus 1, 0, minus 1. This value is 1.75. This minus 1 by 2 means minus 0.5. Then 0. Minus 1 by 2 means minus 0.5. Sum of these two is 0.7. V1, V2, V3. Now we need to identify this current. What is the current I1, I2, I3? What is I1? The current at the node 1. So this 4 ohm is coming towards the node 1. So it is plus 4. But 3 ohm is going away from the node. So minus 3. 4 minus 3. 4 is coming towards the node 1. But 3 ampere is going away from the node. So 4 minus 3. Right? This 4 ohm is coming in. But 3 ohm is going out. So 4 minus 3. At the node 2. This 3 ampere is coming towards. But this 4 ampere is going away. So 3 minus 4. Right? 3 ampere is coming towards, so plus 3. 4 ampere is going away, so minus 4. At the third node, this 4 ampere is coming inside, but another 4 ampere is going outside. So 4 minus 4. Right? So based on the current direction, we can write. So 4 minus 3. 4 minus 3 is 1. 3 minus 4 is minus 1. 4 minus 4, 0. Now framed the equations. Now frame the matrix. This is the current matrix, voltage matrix, and this is the resistance matrix. Now we can find the del value. 4 values are available. Del, del 1, del 2, del 3. From that we can find V1, V2 and V3. So this resistance matrix is nothing but the del. It termed as del. If you replace the first column with the current is del 1. Replace the second column with current matrix is del 2. Replace the third column with current matrix is del 3. Now we'll go for the finding the delta value. Now consider this is the delta. This is a resistance matrix. It's termed as delta. By finding the determinant, we can find this delta value. How will you find the determinant? First you take the first element 1.4. Then what we need to do? We need to multiply these two. 1.7 into 0.7 minus 0.5 into minus 0.5. Already you know how to find the determinant, so you can easily find that. So 1.4 into, you have to multiply these two values minus these two values. While going to second element, we normally will put negative, but already here negative is there, so it become positive. So what will happen here? Plus 1, we have to multiply these two, minus 1 into 0.7 minus 0.5 into 0, so it become 0. The third element is automatically 0, right? First you have to take this element, you have to multiply these two minus these two. Take the second element, while taking second element we need to put negative. Then you have to multiply these two elements minus these two elements. I will go for simplification. So 1.4. So 1.75 into 0.7 is 1.225 minus 0.5 into 0.5 is 0.25. This negative is there. These two negative become positive, but another negative is available. Plus 1 into minus 1 into 0.7 means 0.7. So 1.4 into these two value, by subtracting these two, 0.975. So 1 into minus 0.7 is minus 0.7. So multiplying these two, 1.365 minus 0.7. So by subtracting this, what we got? 0.665. The delta value is 0.665. Now we'll go to the delta 1. By replacing the first column with the current matrix, we'll get the delta 1. So the delta 1. So first column is replaced. 1 minus 1 0 is nothing but the current matrix. Remaining are as it is. Now we'll go to the determine. We determine this 1 into, you have to multiply these two, 1.7 into 0.7 minus, multiply these two, minus 0.5 into minus 0.5. Then second term minus 1. Already we normally will put negative here. Already one negative, so it become plus. Then you have to multiply these two, minus 1 into 0.7 minus these two. These two already 0 is there, so automatically it becomes 0. The third element also 0. Now we'll go for simplification. 1 into 1.75 into 0.7 is 1.225 minus 0.5 into minus 0.5 is minus plus 2.5, but already one minus is there, so minus 0.25. So here minus 1 into 0.7 is minus 0.7. So 1.225 minus 0.25 is 0.975 minus this 0.7. So the final value is 0.275. Delta 1 is not delta 2, so delta 1 is 0.275. Now we calculated the delta 1 value. Now we'll go to the delta 2. Now we'll go to the delta 2. Delta 2 means the second column is replaced by the current matrix. Right. Now 1.4 into minus 1 into 0.7 minus 0.5 into 0, so that becomes 0. The second time normally we'll put minus 1 minus. Then 1 into 0.7 minus 1 into 0.7 minus these two value while multiplying it's 0. The third element automatically 0. So 1.4 into minus 1 into 0.7 is minus 0.7. Minus 1 here also minus 0.7. So 1.4 into minus 0.7 is minus 0.98. So minus 1 into minus 0.7 is plus 0.7. So by adding these two, what we got? Minus 0.28. So the delta 2 value we got negative minus 0.28. Now we'll go to the delta 3. Delta 3 means the third column is replaced by current matrix. So 1.4 into 1.75 into 0 minus minus 1 into minus 0.5. Then plus 1. Here negative is there, so it becomes plus 1. But both are 0. Minus 1 into 0, 0. This minus 1 into 0 also 0. Then third element 1. Minus 1 into minus 0.5. This become 0. So 1.4 this time is 0. Minus 1 into minus 0.5 is 0.5. But one negative already there, so minus 0.5. This time is 0. Minus 1 into minus 0.5 is plus 0.5. So 1.4 this minus 0.5. 1.4 into minus 0.5 is minus 0.7 plus 0.5. So it is minus 0.2. Delta 3 also we got negative minus 0.2. From this delta 1, delta 2 and delta 3 value we can find V1, V2 and V3. So V1 is nothing but delta 1 by delta. 0.275 divided by 0.665, that is 0.4135 voltage. V2 is delta 2 divided by delta, minus 0.28 divided by 0.665, that is minus 0.421 voltage. V3 is delta 3 by delta, minus 0.2 divided by 0.665, that is equal to minus 0.3008 voltage. So we calculated V1, V2, V3. Node voltages are calculated. The same problem solved by equation method. The link is available in the description box. The viewers can see the problem solved by equation method. Thank you.